This is a lecture from Open Tuition. For the free lecture notes that go with this podcast, please visit opentuition.com. We're going to go through question 2 of the June 2011 paper F5 exam. So make sure you've got the question in front of you. And as always, look straight at the requirements before you read the body of the question. Part A, establish the demand function equation for air conditioning units. Calculate the marginal cost for each air conditioning unit after adjusting labour cost as required by the note above. And 3, equate marginal cost and marginal revenue in order to calculate optimum price and quantity. So you should immediately know it's a standard pricing unit. A standing pricing question wants the demand function marginal cost, and then marginal cost equals marginal revenue. Part B, the written part, for 8 marks. So it's quite substantial. You can't rely on getting full marks in the numbers, so it's important to I've certainly got a few marks in the written, but again, fairly standard. Explain what is meant by penetration pricing and market skimming. Well, that you should have learnt, that's in the textbook. But secondly, discuss whether either strategy might be suitable for heat company. So part of it is pure textbook, describe the two, but then to get high marks, it's then discussing which of the two might be suitable, or both of the two maybe. We'll have a look. Anyway, let's now look at the body and do a part 1. So a very quick read of the requirements, but I'm looking for the bits that go with this demand function. And even before, get the formula written down. Get you half a mark if nothing else, but from the formula sheet, we're after an equation of the form P equals A minus BQ, where Q is the demand and P is the selling price per unit. So all I want initially is the information for that. But now let's have a read. We specialise making air conditioning appliances. We're about to launch a new product, a unique air conditioning unit, unprecedented levels of air conditioning, minimal amount of electricity. The technology used is unique and we've patented it, so no competitors can enter the market. The development costs have been very high and it's expected it'll have a 5-year life cycle. We want the best pricing policy we should adopt. Demand is very responsive to price changes, so it's elastic. Research has established that for every $15 increase in price, demand would fall by 1,000 units. If we set the price at $735, so $735 selling price, 1,000 units would be demanded. And the line above, for every $15 increase in price, the demand will fall by 1,000 units. Well, the object here, I'm not going to teach all the reasons for it. We want to get the question done. But if you look at the formula sheet, and we may as well use it, B, first of all, is the change in price over the change in the quantity. So we can write that straight down. We're told for every, what was it, $15 change in price, the quantity changes by 1,000. So B for our formula, 15 divided by 1,000, and be careful you get the decimal places in the right place. It's 0.015. 15 divided by 1,000. I'm always making mistakes there, and it's important, but anyway, that's correct. A is the maximum selling price when the demand is 0. Well, at the moment the selling price is $735, but we're selling 1,000 units. So the price needs to be higher to sell 0, And to sell 1,000 less, therefore 0 demand, we'll put the price up by 15. Put the price up 15. Again, demand's 1,000 less, which would be 0. That's what we want. So A is 750. So now we've got it. The demand function, P equals A, 750, minus B, 0.015, Q, the demand. 3 marks. 2. Calculate the marginal cost after adjusting the labour cost as required by the note above. Well, the marginal cost is the variable cost. Per unit. And they've given us a cost card there. So materials 42, no problem. Labour 12, but there's a note which I'll read in a minute. Fixed overhead 6. Well, we're not interested in the fixed overheads. We're only interested in the variable, the marginal. But we better read the note on labour. The first air conditioning unit took 1.5 hours to make and labour cost $8 an hour. That's what they've got on the cost card. But there's a 95% learning curve. But it's expected to finish after making 100 units. The management has said that any pricing decisions should be based on the time it takes to make the 100th unit. So we need the cost, but we'll need the time first. We need the time for unit number 100, the 100th unit. It's learning curves. We've got the formula on the formula sheet. And they've given us the value of B, minus 0.0740005. So, again, it should be standard. If ever you need to know the time for any one particular unit, we can't do it in directly. We can find the total time for 100 units. I'll just set up a pro forma. If that'll give us the total time for 100. If we subtract the total time for 99, then I'll be left with what I want, the time for the 100th. And how can I work out the total times? Well, remember the formula gives us the average. So for 100, it'll be 100 times the average time per unit, and similarly 99. So we need to use the formula to work out the average time in each case. So as workings, if we're making 100 units, then the average time, y equals ax to the power b, where y is the average. A is the time for the first, which is 1.5 hours. X is the number of units, 100, to the power b, minus 0.074005. Now, I can't really give calculator lessons on here. Every calculator, not every, but the different calculators do it different ways. But if I do the last bit first, 100 to the power 0.074005 negative. I'm not going to write it down, but I get 0.711197138. Sorry, I will, but don't write it down in the exam. But keep it in your calculator, multiply by 1.5, and I get 1.066795706. Well, again, keep it in your calculator, and the total time will be 100 times that. It comes to 106.68 hours. Similarly, if we're making 99 units, the average time y, a, the time for the first, x, the number of units, to the power b, so 99 to the power 0.074005 negative. It comes to 0.7117. Multiply by 1.5, and I get 1.067589458. Again, I wouldn't write it all down in the exam, but to get the total time, multiply by 99. And to 2 decimal places, I get 105.69. So the time for number 100, subtract the 2, or subtract one from the other, and I get 0.99 hours. Now I can get the variable cost. The variable cost of the marginal cost, it's the materials, they're variable, plus the labour. Well, it's $8 an hour, 0.99 hours at $8 gives me a total of $49.92. I think the examiner got slightly different, but that's purely rounding, no problem. So that's part 2, 6 marks. Finally, part 3, equate the two to calculate optimum price and quantity. Well, we know what marginal cost is, but what about marginal revenue? Well, the marginal revenue is A minus 2BQ from the formula sheet. And we do work them out above. A was 750. B was 0.015, so 2 times it, 0.03Q. Make the two equal. Marginal cost equals marginal revenue. Rearrange and divide. Q, 750 minus 49.92 divided by 0.03. Q comes to, again, maybe a little bit of rounding, but that's irrelevant. 750 minus 49.92 divided by 0.03. 23,336. But we're not there yet. They want optimum price and quantity. Well, there is the optimum quantity. The optimum price, we're going to have to go back to the price-demand equation, which we worked out earlier. We know what Q is, 23,336. And so the best selling price .015 times is 399.96. That's 1 cent different from the examiner's answer, but that is purely rounding. That would have got full marks. So we're doing very well in the time, I think. That's 12 marks. However, we better make sure we've done part B, although I've got part A right. There's so many silly mistakes you could have made. You'd still get most of the marks, but you still need a good part B. Explain what is meant by the two. Well, first of all, penetration pricing. Penetration pricing, it applies not only, but very much to new products. It's where we start selling the product at a low price in order to gain market share. It's a very common strategy. Start selling at a low price. Hopefully people change from existing products and start buying our product. We'll get market share. It's always with the intention of raising the price in the future. What about price skimming? Price skimming again is very much for new products, but it's when you've got a product that people want, you start selling at a high price if it's a product people want, then rich people will be prepared to pay a high price to be the first people to have it, to attract customers who want to be the first users. However, there's only going to be a limited number of people who can afford a high price, so it's with the intention of reducing price in the future. New technology is a good example of this. DVD players. Start selling them at a high price. There'll always be some rich people who want to be the first people on the street to have one. And then gradually reduce the price. You run out of rich people, so then reduce the price a bit, and the people who are not quite as rich buy it, and so on. So everybody's paying as much as they can afford. Well, that's the definition part of the question. But that's not enough. It does say explain what's meant by the two strategies. Discuss whether either might be suitable for HeatCo. Well, here's where the first paragraph is relevant, because until now, the first paragraph has been completely irrelevant for the numbers. Let's have another look. And I'll write things down as I come to them. But our company, Heat Company, it is a new product, and both of these are more useful for new products, so far both are suitable. It's unique. Unprecedented levels of air conditioning, minimal amount of electricity. Well, the fact that it's unique tends to make me think of a price skimming approach, in that it's attractive to customers. Next sentence. Again, it's unique. We've patented it so no competitors can enter the market. Well, if there are no competitors, I'm not saying penetration pricing is out of the question. I mean, presumably they're buying existing air conditioning. But the fact that ours is different and that it's patented, nobody can enter our market and charge a lower price. So again, this would suggest a price skimming approach would be better. Development costs have been high, and it'll only have a 5-year life cycle. Well, again, penetration pricing is a possibility here. They could consider it, but very often penetration pricing, you're losing money. But it's worth it if you gain market share and make a lot of money in the future. But here we've only 5 years to get the money, and we've already spent a lot on development. And so again, it would seem that price skimming is more attractive because that stands to make extra profit. Penetration pricing stands to lose it. So again, price skimming to get profits quickly. So my overall conclusion is that although either policy, both policies should be considered, or both strategies, we need to do market research and things. But price skimming looks the more attractive of the two. And there we are. Again, read the examiner's answer, but she's not really written anything extra, and I am confident that that would give me, if not 8 marks, it'd certainly give me 7 marks, which is quite sufficient. And although we finished the question, learn something from the style of it, the examiner's style. That first paragraph looked initially as though it was just background. It was irrelevant to the numbers completely. It didn't need to be there. But the examiner doesn't waste her energy. That first paragraph really is the core of the second bit of Part B. Explain the strategies, but when it comes to which is more suitable, that's where the first paragraph was relevant and all the clues are there.